This is for Year 11 methods. It comes out of 18E question number 8. It's a maximum and minimum problem. And remember, the structure that we have to solve maximum and minimum problems. 1, understand the context. Draw a picture, draw some diagrams, get some situation to understand what's happening. 2, write a rule in terms of x or one variable. 3, take dy dx, so take the derivative, set it equal to 0, solve for x. And then 4, answer the question. So go back to the context and work out what's actually being asked. So if that is the situation, I've got to understand the context. A rectangular sheet of metal measuring 50 centimeters by 40 centimeters. So I've got a rectangle. It's 50 by 40. Congruent squares of side length x. Congruent means identically the same. Is cut out of the corners, which will leave that. Along the dotted line we fold it, and we're going to fold it into a tray that looks like this. So when I cut out the corners, I'm going to lose these bits. And that's going to fold into a tray. Now, since I'm going to lose those bits, this bit along here is 50 minus 2x. This bit here is 40 minus 2x, because I lose an x there and I lose an x there off my 40, and I lose an x and I lose an x off my 50. So that's x, that's 40 minus 2x, and that's 50 minus 2x. Given the fact that I've got a box, x has got to be bigger than or equal to 0. This tells me that x has to be less than or equal to 20, because I can't have x bigger than 20, otherwise that would be negative. And this tells me that x has to be less than or equal to 25. If I consider a number line, it's got to be bigger than 0, less than 20, and less than 25, which means x has to be between 0 and 20 for this box. Okay, so my volume, I'm going to maximize the volume. Volume is length times width times height, so x times 40 minus 2x times 50 minus 2x. So there's my expression for volume. I will select it, go to Math 2, pick derivative with respect to x, take that answer, set it equal to 0, solve for x. Okay, and I get two answers. 15 plus or minus 5 root 21 on 3. I might have a look at these answers in decimal. I like 7.36 because it fits within my domain. I don't like 22 because it's too big. It doesn't fit inside my domain. So I'm going to take the smaller of the answers, which means that x equals 15 minus 5 root 21 on 3 centimeters. Find the value of x for which the volume is a maximum. That's the value of x for which the volume is a maximum.